why chemical reactions happen and some of the factors that affect the rate of those chemical reactions. But why take my word for it? Take science's word for it! Can I just fire my writing staff? You're probably wondering what the scribblings behind me are. It was a feeble attempt to try and relate the energy released upon reaction of things and kinetic energy and things go boom and there's stuff. But then I found some new chemicals that I can work with, and they're so much better. So yay. New ideas. The chemicals I will be using are hydrogen peroxide and diphenyl oxalate. And as most of you may know, I still live with my parents, and my mom doesn't trust me with chemicals, probably because she doesn't understand science. So you're probably wondering, where did you get diphenyl oxalate? And is it dangerous? The answers to those questions are Glowsticks and not really, respectively. How a glow stick works is there's a glass vial inside a plastic casing designed to break, and it's filled with hydrogen peroxide. The outer part is filled with diphenyl oxalate and a fluorescent dye. When the glass vial breaks, the hydrogen peroxide is released and reacts with the diphenyl oxalate. The energy released from this reaction excites the dye's electrons, and as they return to their ground state, they emit light. This process is called chemiluminescence. Let's get back to the real thing. Rates of reaction. The faster the reaction, oh my god, there was lightning. Temperature is the easiest to test. All we have to do is put some glow sticks into water baths of different temperatures. Recall that at higher temperatures, the rate of reaction increases. So if I put this glow stick in the hot water, it should glow brighter. Let's find out. Oh wow, I was not expecting that color of green. This water bath, well, it's a glass of water, is warm. So if I put this in here, it should glow brighter than if I put it in one of room temperature. Is it even working? This doesn't, I don't think it's hot enough. This one's cold. Let's see what happens. Refreshing! Ha! It worked! This next one seems painfully obvious. It has to do with surface area, but kind of concentration, but kind of, I don't even know what. If I crack a glow stick in one spot and don't do anything with it, and then if I crack another glow stick all the way, and then I shake the crap out of it, it'll glow brighter than this one, which I think is obvious at the top there. It's not really rates, but it kind of is rates because we're dealing with chemiluminescence, so it's kind of rates. Finally, we're going to test concentration. Diphenyl oxalate, it's an irritant. If you get it on your skin and you don't wash it off, you're probably going to get a really minor rash. The reason I'm telling you this is because we're going to cut some glow sticks open, and my lawyer was like, that sounds like a bad idea, and I'm like, dude, it's all non-toxic. But he was still like, it's a bad idea, so don't try this at home. Try it in a chemistry lab. There are two ways we can test concentration. We can do it by dilution or distillation. I'm gonna go with dilution because that's a lot easier, because really I just gotta cut a glow stick open and then pour it in some water. We're doing with, what color is that, orange? I don't know how to do this in the dark. Oh my god. Oh my god. Glow stick. Glass. Boom! Well, so this is the glass vial. Hydrogen peroxide comes in a little glass vial. How do I break it? How do I break it? Oh, there's diphenyl oxalate everywhere. This did not go as planned. Get back in there. There we go. I don't know how I thought this was a good idea. Got it on my hand. Bear with me. Okay, how come it's a different color? So I just diluted that a whole lot. So, crap, it's non-polar. Diphenyl oxalate is non-polar. I'm an idiot. Congratulations, Remi-Rix, you learned science. I made a two-tone glow stick somehow. The point I was trying to illustrate is similar to what happens when you drop food coloring into a glass of water. If you do like 1 drop
per 500 mils, it's gonna look different if you put in 10 drops per 200 mils. I was trying to demonstrate that with chemiluminescence, but then a little thing called polarity got in my way. I actually have a video about chemical polarity. There's a link in the sidebar. My mom is gonna kill me. Oh crap. So we all have our special moments, and apparently that was mine. For fear of getting sued, do not try this at home. I realize now that the danger with opening up glow sticks is the glass. I was so focused on the chemicals and the dangers of the chemicals, which there really aren't any unless you drink them. I got so focused on that I forgot that inside these harmless looking glowy things is sharp glass. I got it all on my fingers and all in my feet. Diphenyl oxalate is also all over my face and hands. It's non-polar, which makes it horrible to clean up because it doesn't wash away with water because it's not polar. Water's a polar solvent. Just, guys, just go forth and do science. Not in your parents' kitchen. Oh.